In this video, we are going to discuss Class 11th Mathematics Chapter 1 Sets. Introduction to Exercise 1.3. In this, we will learn the concepts and formula required to solve the problems of Exercise 1.3. See the link below in the description box for the previous videos on sets. Subsets. What are subsets? A set A is said to be a subset of set B if every element of A is also an element of B. And we write symbolically B is a subset of A. The proper subset. A set A is said to be a proper subset of set B if every element of A is also an element of B. So there is no difference between subset and proper subset so far. And A is not equal to B. That is another condition. To be a proper subset, the set should not be equal. See, for subset we write this symbol. For proper subset we write like this. Remember, this is the difference. This is for subset. This is for proper subset. Okay. Now we'll see the example. See, let X be all the people of your state. You have got you are living in a country and you are living in a state. All the people in the state belong to set X. And Y is all the people of your country. So all the people living in the state are automatically living in the country. So X is a subset of Y. Also, X is a proper subset of Y. So we'll write X is a proper subset of Y. This is the symbol we use. Here X is not equal to Y. Means Y and X are not equal sets. We'll see another example. Let A is equal to 135 and B is X such that is an odd number less than 6. Odd number less than 6 is what? Odd number less than 6 is 1, 3, 5. Next number is 7. So it is not less than 6. So these are the three less than 6. So B equals to this. This is equal to A and B are equal. A is not a proper subset of B. A is equal to B. Here A is A, then A is B, A equals to A is a subset of B and B is a subset of A. That means all the elements present in A are equal to B and all the elements present in B are equal to A. So A is B, equal. There are equal sets. By definition, these two are A is subset of B, but it is not a proper subset. Not a proper subset. This is the only thing you should remember in this concept. A, you can write it down in arrow like equal set. These A and B are equal sets. Then they are not a proper subset. They are subset to each other, but they are not a proper subset. When A is not equal to B, that becomes a proper subset. Now we'll see some more examples. See, let set A is a population of one state in the country, Uttar Pradesh, approximately 20.3 crores. And set B is population of India. Now you know very well it is crossed 142 crores. All the people belong to UP also belong to India. So A is a subset of B. That is a proper subset of B. Now we have to focus on these three important concepts about this subset. Every set is a subset of itself. Suppose A is there. is a subset of itself. Okay, and this is not a proper subset, so we have to write. Empty set is subset of every set. Empty set because empty set is a subset of A. Why? Because A doesn't have any, phi doesn't have any elements. A is having some elements. So phi is definitely a subset of A. Equal sets are subset to each other. A equals to B. Just we have seen this. So there A is a subset of B and B is a subset of A. But they are not proper subsets. I repeat. To illustrate above, we take some examples in the following sets. Now consider the following sets. A is with 1, 2, 3, 4 elements, B is 1, 2, and C is 1, 2, 3, 4, 5, 6, and D is 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 5, 6. Then you can reduce very easily certain things. B is a subset of A, right? B is a subset of A, B is a subset of C, B is a subset of D. I have put it in a tabular form so that it is easy to find. B is a subset of all the other three sets. A is subset of C. So because 1, 2, 3, 4 is also contained in C, C has got extra elements. A is not a subset of D. Why? 1, 2, 3, 4, 5. Here D is having an extra element. A is not a subset of D because A is the element 4 is not present in D. Agreed? And D is a subset of C. D is a proper subset of D. Why? D 1, 2, 3, 5, 6 is also there and they are not equal. All the elements of D is present in C also and D is not equal to C. Now see this A. A is a subset of A. As I said, all this every set is a subset of itself. Phi is a subset of A. Phi is a subset of all other sets, any other set. Any set, phi is a subset. Look at this. Let A is equal to 1.1, comma 2 and B is 2, comma 1. These sets are equal sets. The order is different. A and B are equal sets. A is a subset of B and B is also a subset of B. That is what I wanted to repeat with another example. Now comes another concept, superset. What is superset? Set A is considered as a superset of B if all the elements of set B are elements of set A. That means, suppose set A is there. It has got 4 elements. Set B is having 3 elements, 1, 3, 4. Set A contains all the elements of B. So set A is the superset of set B. A is the superset of B denoted by this A. This is the symbol, we use it. We use this symbol. It is the superset. That means to the left side, this is बड़ा भाई. This is इसका छोटा भाई. A is the superset of B. Okay. Another concept is power set. What is power set? Collection of all subsets of a set A is called power set of set A. See, let's see the same example. A is 1, comma 2. What are these? All the sets of this set A subsets. This is 1 is a subset, 2 is a subset, 1, comma 2 is a subset, and also 5 is also null set. This is also a subset of any set as you see. So how many numbers are there? Subsets. Number of subsets 4 are there. So PA is set of sets. Is PA power set. Set of power set means set of all subsets. These are all the subsets. The set is which is we wrote everything in the curly brackets. These are all the you can know. These are all the elements. These elements are remember the elements are sets here. Sets here. So we'll take another example. A comma B comma C. Another set is there. What are the number of subsets we can write from them? One is first 5. Second one A, B, C. Then A, B, AC, BC and ABC. How many are there? Total number of sets? 8. See, here n of is number of elements. We call n as the number of elements in set A. The number of elements in PA is the power set. Power set is so the number of elements in a set is denoted by n, the set name within the brackets a set name. Here the power set is the number of elements in the power set is given by this formula. You can say the number of elements in the set is 3 elements are there, right? From this formula we can calculate the power set. Number of elements in the power set is equal to 2 raised to 3. That is 2 raised to 3 is 8. You can count them. This is the formula we can get to get number of subsets available in the power set. Now we'll see its a relevance in the number line. The number line is all the what are real numbers? You know very well, real numbers which can be represented on a number line. All positive numbers this side, all negative numbers this side. And the fractions, the rational numbers, irrational numbers all go in the number line. So what are the number lines? The first topmost is real numbers. All the real numbers are in the number line. Right? Next is rational numbers. Rational numbers means which can be written in the form of P by Q. That is Q is not equal to 0. It can be written in the form of a fraction, P by Q, rational number. Then comes integers. Integers means all negative and positive numbers. Why I am telling this is, you know very well, integers and whole number, 0 and all the natural numbers. Natural numbers are 1 to 1, 2, 3 and infinite up to infinity. See, this is, first you can see, rational number is the topmost, real numbers is the topmost in the number chain of numbers. See, natural numbers here. This is a subset of real numbers. Agreed? This is also a subset of a whole number. This is also a subset different. So this is in this goes like this. This is subset of n is, I will show you in the diagram. N is a subset of R. Okay, I will go to the next video so that next image. See, this is real numbers. You can say this natural numbers contained in whole numbers. Whole numbers are contained in integers. Integers contained in rational numbers, and rational numbers are all contained in real numbers. Rational and irrational numbers. Both are contained in real numbers. The examples, you can say rational number 2 by 3. This you can see, you all know very well these things. The symbols what denoted by this thing. N is natural numbers, Z is representing the integers, and Q is the rational numbers. Q is the set of natural numbers such that X is equal to the quotient of P by Q, where P, Q are integers and Q is not a 0. This all the elements which can be represented in the number line 5 by 1, this you know very well, which can be expressed in the form of a fraction. P by Q, Q is not equal to 0, or falls under the rational numbers, that is denoted by Q. And next is the set of irrational numbers. This is denoted by P. The P is the X such that X belongs to a real number and X does not belong to irrational numbers. So, or which are not rational numbers are irrational numbers. Like irrational numbers like root 3, root 5, 5. These are the examples of irrational numbers. They are not non-terminating. Means they can be, means they don't end any, they cannot be written in the form of P by Q. That is the definition of irrational numbers. Elements of that include T include 2 pi. Okay, this is some of the obvious relations among this. This is important for you. N is a subset of Z. Also, Z subset of Q. Q is the subset of R. T is a subset of real numbers R. N is not a subset of T. For that matter, Z is not a subset of T. Q is not a subset of T. Why I'm mentioning this, you know very well all this, but in the context of set theory, we are getting these relations. Now, we'll write intervals as subsets of real numbers. So we need intervals. Intervals means what? In the number line, anything number from 0 to 2. This is, and you can write down as an interval. And minus 1 to 3 is an interval. Minus 1 to 3 is an interval. This particular thing is segment is an interval. 0 to 1 is an interval. That way you can write down in the number line means start point, end point. See, now this is, we will follow certain notations. See, open interval. Open interval means A is, see, two start point is A, end point is B. It's an open interval. Means it is, you can see it is it in a, you can see a small dot which is not solid. Not, it is like a small circle. A and B are not included in this interval. A, B are not, these points, the end points are not included. This is open interval. When the endpoints are not included, it's an open interval. A is not in the interval. This is the A to B is the interval. The first point is A, second last point is B, but endpoints are not included in the interval. So this is denoted by A, comma B. These are the brackets. Closed interval means we'll use square brackets. The points are solid dots. This A, B is the interval, and both A and B are included in the closed interval. In the interval, A and B are included. We'll write A and B, right? Now here this is semi-open intervals. Two semi-open intervals. First point is included, last point is not included. In that case, we'll write A is less than or equal to x. A is less than or equal to x. X such that less than or equal to A and less than B. That means B is not clearly not included. A is included. This is not B is not included. This is semi-open interval. Similarly, A less than x less than or equal to B. This is B is included, A is not included. This is also a semi-open interval. This is we can the same way the A is a open dot and this is B is a solid dot. You can represent solid. This is how we represent it. Now we'll see a small example. Set of numbers between two real numbers A and B is called the interval. See, two real numbers A and B. See, we'll write it in the like this. A comma B belongs to real number. A is less than B because A is to the left of the number line. To the left of A is here and B is somewhere here. So from here to here, we are writing the interval. Okay. This is the interval. A is less than B. So open interval means, as I said, example, let us see. -2, 3. See, -2, 3 means, you can see -2 here and 3 here. -2 and 3. Both are not included in this. -2 is there and 3 is there. The interval is A to B. Interval is A to B. And both the endpoints are not included. Interval is A to B. And A comma B are not included. Right? That is how there is a first open interval distinction. Similarly, -2, 3 square brackets. That means here both points are included. A to B, both points are included. The entire interval is all the points are included. Also, endpoints are included. Semi-open interval, which is -2, 3. First one is square bracket. Last one is normal parenthesis. So -2 is, that means this is included. This is a solid dot I gave. 3 is as open circles. This B is not included and A is included. Here also you can see -2 is not included and 3 is included. Square brackets are given, here parenthesis is given. So this is written as -2 less than x and 3 is less than or equal to 3, right? 3 is also included in that. The interval is A to B, B is included and -2 is not included. Now we'll come to the last topic of this introduction part of 1.3. That is a universal set. What is a universal set? See, we may have to consider elements on subsets of a basic set which is relevant to that particular context. For example, I will tell you. Straightforward, simple example is weekdays. See, what are they? Sunday, Monday. We'll start with Yeah, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. This is the set. This is called a set equals to this, and this is the complete set. Any other elements can be possible in this? No. So the complete list of the context under consideration. What is the context under consideration? The weekdays. The number of the names of the weekdays are in this set. The subsets can be, you can have Sunday as subset, you can have Sunday and Monday as subset. Like that, it goes on. The number of subsets, can you tell me? Yes, you guessed it correct. N of power set. It's called power set of V is what? Equal to 2 raised to 7. Okay, this is a huge number. You can take so many subsets, you can make it. And these are the subsets. So the context is important to define the universal set. Universal set need not be unique. Need not be unique. I will tell you why it is need not be unique. So, for example, now we'll study uh, the numbers, system numbers, which are we interested in the set of natural numbers, which is subsets such as set of all prime numbers. Set of all prime numbers belongs to natural number, right? Set of all even numbers belongs to natural numbers. Set of all odd numbers need not be. Actually, set of even numbers can be set of all positive even numbers. You can write positive even numbers. Positive even numbers can be set of natural numbers. Set of all positive odd numbers. Positive and positive. Positive numbers can be set of natural numbers. So like that, this can be. So natural numbers n is the universal set for all this description. In this context, universal set is n, and set of all odd numbers, positive, odd, positive, odd, positive, even, or subsets of the n. So a universal set is denoted by capital U. Remember that. The example, as I mentioned, days in a week, months in a year, January, February, March, that up to December. There cannot be any more months in that, right? Human population of the world. What is this set? You can consider this human population of the set. We will subdivide them: female, male, country-wise population, all subsets, all age group between below 20 years is a subset. People between 20 to 50 years is another subset. Above 60 years is subset, right? Like that, we can have different subsets, but the universal subset is human population. This is the universal. In this context, that is the universal subset. Universal set. That is the universal set. So we are done with the introduction part of the 1.3 exercise. I think you have got the fair bit of idea about the concepts. We discussed subsets, proper sets, power sets, and usually time intervals, definition of the real numbers, and then universal sets. Please go through them. We'll meet in the next video, solution of exercise 1.3.